25. In the xy plane, a circle has center C with coordinates HK. Okay, so somewhere in the xy plane, this is C and it's HK. Points A and B lie on the circle. Point A has coordinates h plus 1, k plus square root of 102, and ACB is a right angle. What is the length of line A, segment AB? Okay. So h plus 1. So there's this circle. Oh, that's an awful circle, ain't it? Whatever. Right? So h plus 1, k plus square root of 102. So it's somewhere over here because it's x, the x value, one more. So this is not drawn to scale. I'm not using the grid in the background. I'm just saying went over 1. Okay, and this has a coordinate h plus 1, k plus square root of 102. Okay. And this is point A, and ACB is a right angle. So AC, let me rewrite this HK over here. Okay, ACB is a right angle. What is the length of AB? This is what we're trying to find. The hypotenuse of this right triangle that we've created. Now I know this is a circle and both A and B are lying on the circle. So AC and CB are both radii of the circle, so they are the same. The circle has a radius the same all the way around, right? So I know AC and AB are the same. This is an isosceles right triangle. So the thing we know about isosceles right triangles is they are 45, 45, 90 right triangles. And while we absolutely can use Pythagorean theorem in these cases, there's also this fun little shortcut that we probably learned in geometry, which says if this side is A and this side is A, this side is A times the square root of 2. We'll come back to this in a minute. All right, going back to over here, our triangle inside this circle. What I need to do is I need to figure out this distance. How do I find out the distance? We're going to use distance formula. So distance formula is if you have 2 points, let's say we have x1 and y1, and we have another point x2, y2, there is a formula that is itself derived from doing this kind of thing of making a right triangle and using Pythagorean theorem, but it is x1 minus x2 squared plus y1 minus y2 squared, and it's the square root of all that. It is just doing a squared plus b squared equals c squared, and then they're deriving this formula from it. I'm not going to go into how it's derived. I have a video down below if you want to see more about distance formula and how it comes up, but that is our formula. I think sometimes they rewrite it the other way and say x2 minus x1 and then y2 minus y1. I've seen it both ways. It doesn't matter. Just make sure that whichever ordered pair you pick, like if you pick this one to be your first one, make sure it is taking up the first positions, and then if that's your second pair, it's taking up the second positions, that you're just consistent in that way. That's all you have to do. Okay, so we are going to use this formula. We're going to, it's going to be big over here. All right, so first I'm going to take this and I'm going to subtract the coordinates for point C. I'm going to take the coordinates for point A and subtract the coordinates for point C. So h plus 1 minus h squared, the x coordinate for A minus the x coordinate for C squared, plus k plus square root of 102, that's our y coordinate for A, minus the y coordinate for C, which is k squared. Now, it looks messy at first, but hey, those h and k's, they're going to disappear. I'm going to be left with just numbers, which is why we're able to have just numbers in our answers. So first, h minus h, because we can view this as plus a negative in both cases. So we can do this. We can say h plus a negative h. Those cancel out, leaving just 1. I have 1 squared. And then I have k and a negative k cancel out, so I just have square root of 102 squared. And all of this is square rooted. So I have the square root of 1, square root of 1 squared plus square root of 102 squared. So first that square root, that 1 squared is just 1. The square root of 102 squared is 102. So that is the square root of 1 plus 102, or 103. So now I know my radius is the square root of 103. And I think if I recall correctly, for the answer key for this one, the College Board actually went at this point through another Pythagorean theorem, I think, to find the hypotenuse. I'm like, why would you do that when we have our little shortcut? If you need to do that, that's fine. But if you can remember this shortcut, or if you reference it, because it's one of the included references for the math section, dude, just use that. Save yourself the pain. So I know now square root of 103 is my a. So to find the hypotenuse, I just multiply that by the square root of 2. So square root of 103 times the square root of 2. You just put those both under the same radical. The square root of 103 times 2. So the square root of 206. And that's a. That's it. Square root of 206 is your answer. Yeah, that one's a bit messy. But distance formula, which does not often show up on the SAT, I was kind of surprised to see it. But yeah, they do like to throw those things in on occasion. Hey guys, head over to my new site, mathwithalyssa.com, to get your free 10 video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.